Hello everybody, how you doing? This is Mr. Dowse. Sorry I'm not here in class today, but my son is sick. Today's lesson is over two very special right triangles. One is the 45-45-90 triangle. The other one is the 30-60-90 triangle. So this particular set of notes is going to be over just the 45-45-90 right triangles. But what this refers to is a right triangle that has a unique ratio between its sides and angles. So in a 45-45-90, keep in mind that since we have two angles are the same, the sides opposite are going to be the same as well. So a 45-45-90 right triangle is actually an isosceles triangle. So if we knew one of these sides here that are opposite the 45s, we actually know both of them. So, and then beyond that, if we know one of these sides here, we can multiply it by the square root of 2, which I know is unusual. But whatever the side lengths are, for example, if x was, let's say, 5, if this side length was 5, so is this one. And then if we just multiply that by the square root of 2, you would actually get the side length for the hypotenuse. And you can leave it as 5 times the square root of 2. You can also just type in 5 second square root 2 and make the decimal here. I'm going to round all my answers to the nearest tenth. So you could also have called this like roughly 7.1, but 5 square root 2 is actually the preferred way of doing it because it's more accurate. Whenever you round this, you're actually making it less accurate. By leaving it as 5 square root 2, it's the preferred way of doing it. But if you prefer to the decimal, I'll accept either way. The decimal version rounded to the nearest tenth, or just the radical right next to it. And so the trick is behind all this, and I'll do this example down here, is I follow these steps here, 1, 2, and 3. For step 1, it says label the sides opposite the angles. So opposite the angles labeled 45 degrees, I label x. So opposite the 45 degrees, I label these sides x. And then opposite the 90 degree angle, I label the hypotenuse x square root 2. Because that tells you the ratio of all the sides. And then it says solve for x. Well, here we don't need to solve for x because x is actually 3. And then from here, it says substitute the new value into x. Well, the new value is 3 in this case. So in this particular problem, since x is 3 here, x is going to be 3 here. And then this x is going to be replaced with a 3 instead. So that's 3 square root 2. And that gives me the side lengths that I was missing in this particular example. So AB is 3, so is BC. It'd be 3 inches. You can leave the units off if you want to. And then the hypotenuse, AC, would be 3 square root 2 inches. Again, you can leave the units off, but this has units on it, so I'm doing it. You can also, again, have done 3 second square root 2, and we get 4.2. So I would also accept 4.2 inches as well. And so there's one thing I wanted to point out here, and I just can't remember what it was. If I come across it, I'll remind you. But there's one more thing I thought might have been useful, but I just can't remember. Oh, here it is. So the legs here, again, are always going to be the same value. And so the sides opposite the 45 are the legs. Hypotenuse is always going to be whatever the legs are times the square root of 2. So let's do a couple practice problems here. And if you want to try this yourself, you can, but I'm going to keep going on this video. So let's see here. So we need to find the missing side, FG and FH. Given the information that we have here, and again, I'm going to follow these steps that I have up here. So first one says label the sides opposite the angles. So I'm going to label the x, and the x square root 2. So opposite this 45 here is x. Opposite this 45 degree angle is also x. And opposite the 90 is going to be x square root 2. And then the next step says, let's solve for x. Well, x is given to us. X is actually 6 in this case, 6 millimeters. So this x is going to be 6 as well, and then this hypotenuse would be 6 square root 2. So FG would be 6. I'm going to leave the units off. And then FH, the hypotenuse, would be 6 square root 2. And again, if you want to convert that to a decimal, you can always do that, and I get roughly 8.5. So 8.5 if you wanted to. It would be millimeters if I wanted millimeters. Now the second practice problem is a little bit different, because notice I've got the square root of 2 right next to it. So I'm going to follow the same steps here, but you're going to notice the answers are going to slightly be different than what we've had up here. Again, we're also given a leg in this case. So in all of these, we're given the leg, right? We're given the side opposite the 45, and I'm telling you this is how you can deal with these various situations. So label the sides opposite the angles. So opposite this 45-degree angle is going to be x. Opposite this 45-degree angle, we're going to label it x. And then opposite the hypotenuse is x square root 2. And now notice, again, this triangle has been turned here a little bit. So the 90 is going to be the side opposite the hypotenuse. So that one's going to be labeled the x square root 2. The other two are going to be labeled x's. And then from here it says to solve for x. Well, our x in this case is this 4.1 square root 2. So this other x is going to be 4.1 square root 2 as well. And then this x here is now going to be replaced with 4.1 square root 2. That is what x is. And then I still need to multiply it by the square root of 2. So x is 4.1 square root 2, and then we still need to multiply it by the square root of 2 here, and something unique happens here. You don't want to leave this as is. You can leave kr, or rk in this case, as 4.1 square root 2. But in this situation, whenever you have two radicals that are the same value and you multiply them, this actually becomes 4.1 times 2, and you'll see that when I do this. When I do 4.1 second square root 2, and then you have to hit the arrow key to the right, and you can type in second square root 2 again, or sorry, times. It took it as 4.1, and we just doubled it eventually here. So this actually ends up being roughly 8.2. And if you don't like that, you can do 4.1 second square root 2, hit enter, then times second square root 2, and you get 8.2 as well. So ultimately, 8.2 is the answer here. And again, if you wanted to take this 4.1 square root 2 and multiply it, you're welcome to. We got roughly 5.8 when we did it for the other problem here, so, or the other side. So those are the answers. So again, I know this is a little awkward, but you take 4.1 square root 2, that's my x, and you need to multiply it by the square root of 2. So you can take this and get a decimal and then multiply by the square root of 2, or just take the whole thing and multiply it by the square root of 2 again. You get 8.2 basically. And so that's the idea. So this is the situation where you're given a leg. Now what if you're given the hypotenuse? This one's going to be a little bit different than what we just did. So right here we're given the hypotenuse. So notice on example 2, I've got 10 centimeters as the hypotenuse. On practice 3, we've got 25 feet for the hypotenuse. And then on practice 4, we've got 18 square root 2 for the hypotenuse. So I'm giving you the hypotenuse here. This is as hard as we can make it. So following the first step, again, to label the sides opposite the angles. So opposite the 45s, I'm going to label x. Opposite the 90, this is my x square root 2. And then here it says solve for x. This is mainly the reason why it says solve for x, because we don't know what x is in this case. So we basically have x times the square root of 2 equals 10. And it's my job to get x by itself, because once I know what x is, that's what the legs are going to be here. So this is x times the square root of 2. To undo multiplying by the square root of 2, you can divide by the square root of 2, and it'll cancel out the square root of 2's, and we get x is equal to 10 over the square root of 2. You can leave these as 10 over the square root of 2, because that is what x is whenever you, that's whatever x is when it's by itself. Or you can always just take this in your calculator, do 10 divided by the square root of 2, and convert that to a decimal, and we get roughly 7.1 here. So you can always convert this to a decimal. So you can make this either 10 over the square root of 2 or just 7.1. Either one of those is acceptable. And since one of these is this, either one of these, then this x is going to be the same, because these legs are identical. They're congruent to each other. So you could either write down, 10 over the square root of 2 here, or you can write down 7.1. You don't need to do both. Just choose one and go with it. I would make it consistent, because whenever you take the test on this, 2 classes from now, I'm going to accept either answer here. So I'm actually just going to convert this to, I'll leave this as 10 over the square root of 2, and I'll leave the other one over 10 over the square root of 2. But again, you could have typed 7.1 either way, and that's fine with me. So let's look at this again. Practice number 3. So we are now given a hypotenuse of 25 feet, and it's our job to find the other 2 legs. So I'm gonna label the sides opposite the angles. So we got opposite the 45-degree angles, we're gonna label x. Let me zoom in here a little bit, so I'm not so far away. Opposite the other 45-degree angle, I'm also going to label x. And then opposite the 90, this is my x over the square root of 2. So I have 25 equals x times the square root of 2. And again, I want to get x by itself, because that will give me what these legs are. So I'm going to divide both sides by the square root of 2. And that will get x by itself. And that is the answer to both of these problems. So let's just write that in. 25 over the square root of 2 for both of these. And if you want to, again, you can convert this to a decimal. So what would that have been if it was a decimal? 25 divided by second square root 2, roughly 17.7. If you wanted to go that approach, 17.7. But it's not necessary, again. It's just really your call. And then the last practice problem I have here is the 45, 45, 90 triangles in this case here. But notice the hypotenuse is actually 18 square root 2. You're going to prefer this one over the ones I've done. So I've had whole numbers for these last two examples. Now I'm going to have the square root of 2 here, and you're going to see you're going to like this a lot more than what I've just been doing. So I'm going to label the sides opposite the 45s as x's. And then the side opposite the 90 is going to be my x square root 2. And again, I still want to solve for x here. So, but I have something very nice about to happen here. So I'm going to set x square root 2 times 18 square root 2 equal to each other, because they are equal to each other. And if you want to get x by itself here, you divide by the square root of 2 like we did earlier. But notice something very nice happens here. The square root of 2's actually cancel out. So your x value is just 18. So the hypotenuse had a square root of 2 here. When we solve for x, the square root of 2 goes away. And then we just get 18 for the legs here. So fj is going to be 18. And you can say jp is also going to be 18. This would have been, there's no units here. So that's the idea here. And that goes back to the very first examples we did, where whatever the legs were, we would multiply those by the square root of 2. And so the hypotenuse, like in practice 1, was 6 square root 2. It's the same idea here, but we went backwards. We had 18 square root 2 for the hypotenuse, and then those square roots of 2's go away, so we just get these whole numbers of 18. So practice 1 and like practice 4 are very similar if you just look at the hypotenuses and then the legs. So there was more I wanted to show when it comes to squares, but I'm going to wait and do that the next time I see y'all. So just bypass that. Next video is going to be going over problems 1 through 12. Otherwise, if you have any questions, please come into tutoring. I will have additional other videos on Google Classroom as well. I'm sorry I'm just not here today, but I will see you next class. Bye-bye.